Taking a look at the third form of a linear equation, which is called the standard form, we're going to see that the nature of this equation is a little bit different than some of the other equations we've dealt with. So the format is ax plus by equals c, where a, b, and c are integers, so no fractions or decimals allowed, and a must be positive, so this first number can't be a negative number. Either of the other two can, but the first number cannot be a negative number. And a and b are both not 0, so we can't take out both x and y from the equation. We're going to take a look at how can we do things like graphing from standard form to get started. So there's sort of two methods, and it depends on the equation you're given. So we have method number 1 on the left and method number 2 on the right. Looking at method number 1, here's our first situation. If a and b evenly divide c, then we can graph using the x and y intercepts. So the point where the line crosses the x-axis and the point where the line crosses the y-axis. So here's what we mean by a and b evenly dividing c. Notice we have 3 and 4. So a is 3 and b is negative 4. C is 12. Since 12 is evenly divisible by both 3 and negative 4, we can use this method for this problem. When we do this, we use the fact that in an x-intercept, y is equal to 0, and in a y-intercept, x is equal to 0, to find 2 points that are on the line. So let's find the x-intercept first. If I put in 0 for y, I'll have 3x minus 4 times 0 equals 12. Now, if I multiply a number by 0, it's just 0. So this equation is really just 3x equals 12. If we divide both sides by 3 to solve for x, x is 4. So I can take and put 4 into the table, and I can see that the first ordered pair that I can graph is the point 4, 0. Next, I want to find the y-intercept. So I'm going to put in 0 for x. So 3 times 0 minus 4y is equal to 12. Again, 0 times anything is 0. So this is just negative 4y equals 12. And if I divide both sides by negative 4, then y will equal negative 3. So that gives me my next ordered pair on the line, the point 0, negative 3. So this one is my x-intercept, and this one is my y-intercept. So when I go to make the graph, I'm going to start by graphing those 2 points. So I have my x-intercept at 4, 0, and I have my y-intercept at 0, negative 3. Now that's great that it gives me 2 points, but whenever possible, I'd like to have more than 2 points shown on my graph. So I need to think about what the slope would be. So if I look at this, if I start at the leftmost point and then go up to the uppermost point on the right, I can see that my change in y is a positive 3, and my change in x is a positive 4. So if I go up 3 over 4, that would actually put me out here, so that's not quite going to fit on my graph. But if I go down 3 back 4, I can get 1 more point to fit on this grid. And that'll make it just a little bit easier to draw this line in. So I can see that my line goes like this. And I already have 2 points labeled on the line, so I don't have any additional work to do. All right, not all problems work out quite so easily. The second situation I might have is like this next one. Graph 3x plus 4y equals 8. So a is 3 and b is 4, which sounds really familiar. It's almost the same as the last problem, but this time c is 8. And notice, although c is divisible by 4, it's not divisible by 3. So I can't use that handy little method that we just used on the left. Instead, I have to use the method of solving for y to get it into y equals mx plus b form, and then graph the same way we graphed when we were in y equals mx plus b. So to start, we're going to subtract 3x from each side. Since we know we're trying to make this look like y equals mx plus b, I'm going to write the negative 3x first, and then since a is positive, I'm going to add 8. Next, I'm going to divide both sides by 4. So that means I have to divide both parts, like distribution. So I have negative 3/4 x plus 2, and that's my y equals mx plus b. So I can see my slope will be negative 3/4 from a starting point of 0, 2. So when I go to my graph, that's how I'll proceed. I'll start at 0, 2. I will go down 3 and right 4. I can also go up 3 and left 4 to get enough points on the graph. And I can draw my line going all the way across, just like we've done with all other forms. In this case, I'm probably going to label that y-intercept, and then one of those other 2 points I'm choosing to label for -1, but you could certainly label the other one instead. So those are our 2 methods for graphing from standard form. Down below, we just see a quick summary of all the different ways that we've learned how to graph. The T-chart is sort of our least preferred method for graphing. It's what we use if we just don't remember anything else to do. When we're in slope-intercept form, we can use the slope and the y-intercept to graph. So we're typically going to use that when we have an equation that gives us the slope and the y-intercept. If I'm in some other form of the equation, I can always solve for y to get it into this form and then graph from there. The point-slope form I find is one that students tend to neglect a little bit. But it's much faster to graph using the information in the form rather than converting this to some other form when you're given point slope. So you want to remember that you've got your slope and you start at the point x1, y1 to graph from there. ax plus by equals c is the form that we're learning today. This requires graphing from x and y intercepts whenever possible. But if a and b don't divide evenly into c, we can't use that method. Sometimes we have to solve for y.